Hello and welcome to a lesson on factoring a sum or difference of cubes. Just to recap where we've gone on this journey in this module, we started by looking at factoring out GCFs, which is the first step in any factoring process. And then we said if we've got four terms in our polynomial, then we're going to try to factor by grouping, which is basically GCFs again. If we've got a trinomial, we're going to try to factor that trinomial using bottoms up. And then if we have two terms, if we have a binomial, and that binomial represents either a difference of squares, which was our previous topic, or a sum or difference of cubes, then we're going to factor using a different method. Okay? So the sums and differences of cubes, they're probably the most challenging to factor if you're trying to, memorize a process. The good news is we do have formulas that will help us here. But remember, factoring is our process of taking one polynomial and rewriting it as a product of two or more, and it is the reverse of multiplication. So we're going to start with a multiply problem so you can see what the, in this case, or what the sum or difference, either one, what the sum or difference of cubes is going to look like and where it's coming from. So we're going to be multiplying a binomial times a trinomial, which is a different start than the previous topics, and you can see if the result is going to be is going to have to be worked backwards, that this is what we're going to be factoring into, and already that probably looks a little more challenging. But let's go ahead and multiply this out and see what we're left with. The x times x is going to get us an x cubed. X times negative 4x is going to be a negative 4x squared. X times 16 is going to get us a positive 16x. So there's the first three terms. Remember, 2 terms times 3 terms should get us 6 altogether. We're going to get the others by distributing the 4. So 4 times x squared gets us a positive 4x squared. And then 4 times negative 4x gets us a negative 16x. And then 4 times 16 at the end gets us a positive 64. Now when we go to put these terms together, what happens is the x squared terms cancel, the x terms cancel, and we're left simply with an x to the third and a plus 64. And that is an example of, sorry, I got a little squished, that is an example of a sum of cubes. Okay, a sum of cubes. Now remember, this is the multiplying process. When we take our binomial, multiply by our trinomial, and there's a pattern that exists in there. Obviously, we had some terms cancel, but we have to be able to work backwards in this process. We got to be able to take these two terms, which we're going to call a sum of cubes, and figure out what binomial and trinomial we had to multiply to make that happen. And so factoring, in this case, is going to be a little more challenging. Now, just so we're clear, this again is a sum of cubes because these are both the result of multiplying something by itself 3 times. So think about where, get a highlighter here, where the x cubed came from. It came from multiplying an x by an x squared, right? So x squared we know is multiplying x by itself twice, and then we multiply it by itself again. There's our x cubed. And then we think about where the 64 came from, and the 64 came from multiplying the 4 by the 16. Well, the 16 is already 4 squared, so then we multiply another 4 and we end up with 4 cubed, which was the 64. Okay? So we know that the beginning terms are going to get us the cube in the beginning, and we know the end terms are going to get us the cube in the end. Just like in our difference of squares, the beginning terms give us the beginning and the end terms give us the end. But the stuff in the middle is a little more complicated because we got to cancel out more terms. Okay? Now we're going to use formulas, as I mentioned, so this will be a little bit manageable. We do have a formula established when we have a sum of cubes. We do have a formula established when we have a difference of cubes. But in order to use the formula, we have to make sure we can identify a sum or difference of cubes. So what does it mean to be a sum or difference of cubes? Well, we have 3 criteria, just like when we looked at our difference of squares. Still looking for 2 terms, but this time it doesn't matter if they're being added or subtracted. Like the difference of squares, it had to be a difference. Here it can be a sum or a difference. And then instead of our coefficients and constants being perfect squares, this time our coefficients and constants need to be perfect cubes. and we probably aren't as familiar with the cubes as we are with the squares. So this list might be a little bit more helpful. So 1 cubed is 1. So 1 is not only a perfect square, it's also a perfect cube. 2 cubed is 8, so 8's a perfect cube. 3 cubed is 27. 4 cubed is 64. That's another one that's a perfect square and a perfect cube. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729, and 10 cubed is 1,000. So what we're looking for is any of our coefficients, like the 1 here, or constants like the 64 here. We're looking for those numbers to be on this list of perfect cubes. Okay, and now for the squares, we said our exponents have to be even. For our cubes, they have to be divisible by 3. So squares divisible by 2, cubes divisible by 3. That should make sense. So any of our exponents on our variables are divisible by 3. That means we could be 3 or 6 or 9 or 12 or 15 and so on. It's got to be some multiple of 3. Okay? Now how do we go about factoring? Again, we've got some formulas. If we've established that we have a sum of cubes or a difference of cubes, we can apply one of these formulas to try to factor, so that's good. But notice that in these formulas, we're in the form something cubed plus something cubed, or something cubed minus something cubed. In order to use the formula, we have to figure out what it is we're cubing, because that base of that cube, the a and the b, they're going to be used throughout the rest of the formula. Okay? So we need to establish what we're cubing. So for example, the problem we just looked at was x cubed plus 64. If I had to work backwards to factor that, well, I know I'm cubing x to get to x cubed, but I got to figure out what I'm cubing to get 64. And so 4 cubed is what makes 64. I need it to be written in this format in order to work backwards and factor. Okay? So we know we're going to use formulas, but we're going to start this process just like the squares by rewriting our terms as cubes. What are we cubing to get to each of those terms? And just like with the squares, we took the square root. Here we could take the cube root of our coefficients and constants. And then just like with the squares, we divided our exponents by 2. Here we're going to divide our exponents by 3. So we're going to cube root our coefficients or constants if we need to, although we do have a list up here to reference. And then we're going to divide our exponents by 3. And then the formulas, I'll show you straightforward how to use the formula, but I actually, I don't have these memorized myself, and it's not that you're going to have to memorize them because you have access to notes and stuff when you take your quizzes, but I memorize the patterns in the formulas. So if you look at the formulas, they look almost the same, right? The terms, in fact, are all the same. The only thing that's changing are the signs, right? So notice in the sum, if we start with the positive here, then we start with a positive here. And then the sign changes to a negative, and then this one's positive, right? Here we start with a negative, this one starts with a negative, then it jumps to a positive, the last one's positive. So the signs are going to be the same from the start to the start, and then it jumps to the opposite, and then the last one is always positive. Okay, so we have the same sign, and then jumps to the opposite sign, and then always positive. So that's kind of one pattern that I like to remember. Oops. And then also, get rid of all this. We know for factoring cubes that we're going to have a binomial times a trinomial no matter what. So I'm going to start by setting up the parentheses for the binomial times the trinomial, and then I go ahead and fill in those signs. The signs start the same as the original. Or do we have a sum? We're going to start with the sum. Do we have a difference? We're going to start with the difference. And then in the trinomial, the next sign is the opposite of what we started with. So if we start positive, then we jump negative. If we start negative, then we jump to positive. And then the last sign in our trinomial is always positive. Same, opposite, always positive. So if you can remember that pattern, it makes using the formula a little bit easier. Same, opposite, always positive, right? SOAP. Same, opposite, always positive. Okay? And then what's going to happen is the bases of the cubes are going to be what appear in our binomial. So we're just going to drop the bases of the cubes into the binomial. And then into the trinomial, the first term is the square of the first term here. So we're going to square the first base. And then in the middle, if you look in the middle, it's a times b. It's the first term times the second term. So we're going to multiply our two terms. And then if we look at the end of the trinomial here, this end is this second term squared. So we're going to square, and then we're going to multiply, and then we're going to square to get that piece in the end. Okay, and I'm going to run through that verbiage just so you can see how I kind of use the patterns. I remember the patterns to try to factor, but I also straightforward just showed you how to plug into the formula. Okay, so let's look at some examples, and I don't know what I just erased there. I do that all the time. Okay, so here's our formulas again just so we can reference while we're working. Let me show you how I would approach this problem just using patterns, and then I'll show you the next one just using a formula, and you can kind of decide how you like to work there. In either case, if I want to apply the formula use or the patterns, I have to have something cubed plus or minus something cubed. Okay, so here I'm good with the x cubed, right? I'm cubing x, that's already a cube, but what am I cubing to get 125? Well, if I took the cube root of if I took the cube root of 125, which I could use my calculator for, or we could reference the list that we made, the cube root of 125, what are we cubing to get 125 is going to be 5. Okay, if I can type this in, there we go, it's 5. So x cubed minus 5 cubed, okay? So now I know, I can see here that this is what I'm going to be trying to factor into, this binomial times this trinomial. So I'm going to set up my parentheses for my binomial and set up my parentheses for my trinomial. And I know that my signs are going to be the same sign that I started with, then the opposite, and then the last one's always positive. So if this is a minus, I'm going to put a minus here, and I'm going to put the opposite sign, and then my last one's always positive. Okay? And now, into my binomial are going to be the bases of the cubes, just the a and the b, not the cube or the cube. So the base of my cube here is x, that comes down, and the base of my cube here is 5, that comes down. And now I'm going to work on the trinomial. So the first part of the trinomial says to square what I have here. So a squared, take this and square it. So I'm going to square my first term, and x times x is x squared. And then in the middle, a times b. A times b says multiply these two terms. So if I multiply x and 5, I get 5x. And then at the end is b squared, so I need to take my second term and square it. So 5 gets squared to make 25. And now I'm all factored. Okay? So now I went through it kind of slowly there. Let me run through it one more time with you just so you can hear the verbiage. So I'm going to rewrite these as terms, or these terms as cubes. So this is x cubed minus 5 cubed. So I know this is going to factor into a binomial and a trinomial. My signs are the same, so negative, negative, and then opposite, and then always positive. The bases of the cubes are coming down, so x and 5. And then I'm going to square, so x squared, and then I'm going to multiply, so 5x, and then I'm going to square, so 25, and there it is. This is my factored answer. Those are the two polynomials I would have to multiply to create the one difference of cubes that we started with. Okay, so there it is. Let me show you again. Let's see, 8x cubed plus 1. No matter what I'm doing here, I got to start by rewriting these terms as cubes. So what am I cubing to get an 8 and an x cubed? Well, a 2 cubed is going to make 8, and obviously x cubed will make x cubed. And then 1 is already a cube, so I'm going to just rewrite it as 1 cubed so I can see. This is going to factor into a binomial and a trinomial. Signs are going to start the same, so positive, then opposite, and then always positive. And the bases of my cubes go into the binomial. So a 2x and a 1. Then I'm going to square my first term, so 2x times 2x makes 4x squared. Then I'm going to multiply my two terms, so 2x times 1 is going to be 2x. And then I'm going to square my second term, so 1 times 1 puts a 1 there. And there it is. That is my factored answer. Okay, so 8x cubed plus 1 factors into those two polynomials. And then if I wanted, I could multiply that out to check my work, but I don't know that I want to be doing that every time. Okay, so let's try again here. So difference of cubes, what are we cubing to get each of these terms? What are we cubing to get 64? This is going to be a 4, and then obviously an x cubed will make an x cubed, and then y is already cubed, so we're good. So binomial, trinomial. Signs are going to start the same, so negative, negative, and then this one's opposite, this one's always positive. And then it's the bases of the cubes, right, the 4x and the y that are going to come down. So I'm going to have 4x and y in here. And then for my first term in the trinomial, I have to square my first term here. So 4x times 4x, and if that's hard for you to do in your head, 4x times 4x is going to be 16x squared. And then in the middle, I got to multiply my two terms, so 4x times y is going to give me a 4xy. And then at the end here, I got to square my second term, so y times y makes a y squared. And there you have it. Okay, that is it. So if you feel like this is a process you can handle, then this would be a good opportunity for you to pause the video and give it a try. So if you're ready, let's see, x is already a cubed. What are we cubing to get 27 would be 3, so 3 cubed. So binomial, trinomial, same sign, opposite sign, always positive. Bases are coming down, so x and 3. Square, x squared. Multiply, 3x, and then square, that makes 9. Done. Okay, so there it is. Hopefully, I mean, I don't know if you're going that fast. Maybe I went a little too fast. I apologize. I just, I get so excited factoring cubes. Hopefully this is okay for you. Now, let me show you one more with the pattern, and then the last one I'm just going to go straight formula on you and not talk through the verbiage if the verbiage is confusing. So let's try to use the pattern again. We need to figure out what we're cubing to get x to the 6th. And so this is where the divide the exponent by 3 comes in handy. 6 divided by 3 means there had to be an x squared in here. Remember, this is our power rule. If we multiply these, they'll get us back to the x to the 6th. So x squared cubed is going to get us x to the 6th, and then 7 cubed is going to get us 343. So the bases of my cubes are x squared and 7. So this is going to factor into, again, binomial, trinomial, same sign, opposite sign, always positive. My bases, x squared and 7, come down, and then I'm going to square the x squared. So what's x squared squared, or x squared times x squared is going to be x to the 4th. And then I'm going to multiply x squared and 7 to make 7x squared. Then I'm going to square the 7 to put a 49 here. So sloppy, the heck, sorry. And there it is. Alright, now just a couple things. Remember that the first two terms, the first term in the binomial and the first term in the trinomial, those are the two that are creating the x to the 6th term here. So sometimes we get a little confused with the exponents, but in the beginning, if there are two x's here and we have to get 6 back all together, we know that there have to be 4 remaining to go here. So the 2 and the 4 take us back to the 6, right? Or similarly, I've just freaking highlighted everywhere, sorry. Similarly, the 343 in the end here that came from our two end terms. So if I have 7 going here, I have to have 49 going here to go back to the 343. Alright, so sometimes we get a little confused on what's left to go here. But just remember that these last two terms got to give us this term, and then the first two terms got to get us the first term. So things to keep in mind. Okay, how many highlights did I make? Literally hit the undo like, okay, sorry. All right, so let's try this last one just using the formula. I'm going to try to avoid some of my lingo, but whether we want to use a formula or not, I got to figure out what I'm cubing to get each of these terms. What are we cubing? So 729, well, the cube root of 729 is 9. And then if I divide my exponent of 9 here by 3, that means there has to be an x cubed in here. And then the cube root of 8 is going to be 2. So these are now, if I'm thinking about my formula, this is like my a and my b. So a is a 9x cubed, and then b is a 2. So if my formula says that a cubed plus b cubed, that's what I have here, something cubed plus something cubed, is going to factor into a plus b, and then a squared minus ab, and then plus b squared. Then, let me go green now. If I replace a with 9x cubed and replace b with 2, and then here 9x cubed would have to be squared, and then here 9x cubed would have to be multiplied by 2, and then here 2 would have to be squared. Okay, so what becomes of this mess is, well, 9x cubed plus 2, nothing to mess with in there, and then 9x cubed squared, that's really sloppy. I don't know why I'm so sloppy today. 9x cubed is squared, so that's going to get me 81x to the 6th, and then minus 9x squared times 2, which is going to be 18x squared, and then plus 2 squared, which makes 4. So if it's easier for you to just figure out what a is, figure out what b is, write them next to the formula and work through it that way, then that's definitely an option for you. Okay? I know I don't have a lot here, but I want to show you one more just utilizing the formula, so that if, again, the verbiage that I was saying was confusing for you, let me show you one more. Okay? Let's say we were looking at, I don't know, x to the 6th. Let's go 8x to the 6th and then minus 27. Okay? If we rewrote these terms as cubes, what are we cubing to get each of these things? Well, here would have to be a 2 and an x squared. So the cube root of 8 would be 2, and then 6 divided by 3 would put a 2 here. And then we're cubing 3 to get to 27. The cube root of 27 is 3. So that means, in this scenario, that a is going to be 2x squared, and b is going to be 3, right? Those are the bases of my cubes. So my formula says that a cubed minus b cubed is going to equal a minus b times a squared plus ab plus b squared. Well, a, I just said, was going to be 2x squared, so that means a 2x squared would have to go here. B, I said, was 3, so a 3 would have to go here. A squared means 2x squared would have to be squared. A times b means 2x squared would have to be multiplied by 3. And then b squared means 3 would have to be squared. So that would make my final answer 2x squared minus the 3. And then 2x squared would be 4x to the 4th. And then I have a plus. And then 2x squared times 3 would give me a 6x squared here. Oops. Parentheses, silly. And then I have a plus, and then 3 squared would put a 9 here. Okay? So if it's easier for you to rewrite them as cubes and then just follow the formula, that's fine. If the patterns were helpful for you, I'm glad, because that's what works for me. In any case, you have a few practice problems to work out, so give them a try. And if you find yourself struggling, then just reach out and I'll do my best to explain in one way or another. All right? Take care, guys.